Hello everyone, can you hear me? How are we doing? Good evening. I think I was seeing your message from yeah. How are you all doing? Can you hear me? Please, if you can hear me, drop what is it? If you can hear me, type all the names you want to give me. If you can hear me, drop your emojis. Let's start. Let me confirm. I want to join you guys from this system, so I think it's easy for me to see the questions and everything you guys have. And if you can hear me, welcome to today's class. Chemistry, yes. We are doing structure of atom. Structure of atom. Okay, I'm about to join you guys. Yeah. I think that's YouTube, right? YouTube. Are they responding? Can they hear me? Can you guys hear me? Hello? Are they seeing me? Can you hear me? Can you see me? Jesus, beautiful Lord. Let's make today the best of the best of the best of the best. Huh? Hello, everyone. Okay. Yeah, hi, meet she's married the mother-in-law of my mother. Okay, I'm about to join, so I think it's more. Okay, I've seen you guys, yeah? Yeah, so let me just mute this. Okay, nice one. I think I can see messages now. Oh, Jesus. Yeah, I can see it all now, yeah? Triple A, thank you so much. Usman, thank you. Adeyinka Atinuke, how are you doing? Oluwadara Simi, welcome. Ahmad Isa, welcome. Welcome everyone to today's live class. So I'll be using this space to be seeing you guys and then can actually connect. And then the board, let me write this. Can you type out what I write? Or type the last word there. Type it on your what is it called? Type send it as a chat. Let me be sure that you guys can actually hear me. Yeah, but I saw you guys can actually see the board also. Yeah, and also sorry. I wasn't planning to use the house today. But I think let me just say some stuff caught me up. So let's manage the board and everything. So type the last word on the board. Let's see and then let's start. Jesus, I'm growing old. Oh yeah, guys, now type the last word. Type the last word. The last word there. If you can see it, please. I want to be sure you can see what's on the board. Oh, thank you so much, Usman. Thank you so much. Thank you so much, Usman. Thank you so much. Good. I think with that being said, now let's start. So today's class is gonna be like a creative kind of class, more like a biology class but a chemistry class. Ah. Okay. I love that. Okay, just give me a moment, please. Come in, please. Okay. We'll be starting soon. Just I need a moment, please. I need to set this in up very well. think we can actually start now. Yeah. Okay. Okay. No, let's start. Are you ready? Okay, let's start, guys. Now, what's an atom? I'm so excited today. I don't know. I feel like today's gonna be beautiful, like seriously beautiful. I think this is already, what time is this? This is already 1909. Oh, sorry, this is 809. So I've actually consumed 10 minutes without really doing anything much, and I'm sorry about that. We sorted out. I am trying to get less than perfectly sorted out for you guys. Like what I want to achieve this night is just for me to be able to, like, actually see your messages and everything without having to, like, go over there, so you guys can actually be with me all through. You understand? So that's what I'm trying to achieve. Yeah. Now, what's an atom? Are you ready? What is an atom? Before we start anything, first of all, let's start with what science is. What is science? Can you see this? When you say the word science, what does it mean? There are many definitions that come around to define and give us the explanation of what science actually means. Science is a process. Science is a routine. Science is a field. Science is a discipline. Whatever blah 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 you think science is, glory be to God. But one thing I'll tell you is this: science is all about just trying to know something. Trying to what? To know about something. You have to know more. To know initially know. To get to know. To understand something. But in the definitive mode of science, I say what? Science is the systematic process of making an inquiry about both. Let me use my this. Can you hear me? Hello? Hello, can you hear me? Are you ready? Is the mic working? Good. Science is what? Is a systematic process of making an inquiry about both living thing and non-living thing. Is that a message? Okay. It's a systematic process of making inquiries. First of all, it's a process. How can I see this, Mary? Okay, it's a process of what? Of making an inquiry about both living thing and what? Non-living thing. That's science. The process, step by step, identification, classification, all and all and all. But making an inquiry, what does this word inquiry mean? It just means to know about, to find out, to research. It's okay. It's okay. That's all I do. The will. The will. It's just it's network. It's network issue. Okay, are we good? So it's what there's a process of making an inquiry about living thing and non-living thing. Then you ask yourself then, what is this living thing and non-living things? What are these things? What are these specific things? If we look at it like this, we can actually relate this living thing to what we call matter. What happened? It's showing now. It's showing here. It's showing. It's network. Let us say, okay. I'm just home. Sorry? Nothing happened to interactive board. I'm home. I'm not at office, you understand? And I can't go there, the road is actually blocked. And I thought I got home drenched and soaked and all today. So you guys want to see interactive. I really want us to use interactive board for this topic. But absolutely not possible this night. But on Friday, our Friday class is interactive board, not this whiteboard. Hey, man, how come you are ignoring the first wife also the second wife? That's a bad habit of a Yoruba man. Let's go back now. So what is matter now? Matter is anything that has mass and occupies space. And in that simple instance, we can say what matter is almost everything and anything. Apart from very, very few things. So as we can place this T here to M, living matter and what? Non-living matter. So what science is the systematic process of making a inquiry about what? Living matter and non-living matter. Okay? Yeah? Living matter, no question yet. Living matter and what? And non-living matter. Now, why am I going through all this explanation to you? Is because I want us to link it downward. Like I said, we start from the scratch, the bottom scratch. Now, if you now go deeper, science, like I said, is a discipline. Is it my phone is really sound or yours? Why do you plug it in? Why do you plug it in? No, I'm not using it. I'm using my laptop. No. So science has, as a discipline, is broken down into 3 major branches, or 3 pure branches. Number 1 is chemistry, number 2 is biology, and number 3 is physics. Are you following something here? Now if you look at this, look at science studies what? Living matter, I need Jesus. I'm not equipped today at all. Not telling him, discussing nothing. But what has to be done? So science studies on 3 things, 2 things, living matter and what? And non-living matter. Don't forget that. Right? Can they see it? Okay, yes, they can. So science studies that. Now, these 3 guys are the pure branches of science, but they pick different parts. Chemistry studies the non-living part. Physics studies picks the non-living part. The biology picks the living part, the living matter. Are you getting something here? NLM. So I'm not doing this one today. This is what we are doing today. Now this is what we are doing. So what is chemistry? What is chemistry studying in non-living matter? Because these 2 of them took non-living matter, but they approach it from different angles. So what is chemistry doing for non-living matter? This is what chemistry is doing. Please, can you hear me? If you are here with me, kindly drop emojis, please. If you are here with me, drop emojis. Let me be sure you guys are here. If you are here with me, kindly drop emojis. Let me sure you can hear me. I know you can. If you can hear me and you are watching me and you are here with me, drop your emojis, please. Okay, keep it coming. Yeah. Keep it coming. Okay, thank you. I can see your own Daniel. I can see your own Temilade. I can see your own Usman. Keep it coming. Oh, okay, thank Jesus. What is this, Usman? There are similar. Plate of food. Are you hungry? So now, what is chemistry studying in non-living matter? It's studying 4 things: C, P, S, U. Composition, properties, structure, and uses of matter. That's what chemistry is studying. Composition, properties, structure, and uses of matter. What is C? Composition. You can write it down. How to define chemistry? What do you say? Chemistry is a pure branch of science that deals in what? Composition, properties, structures, and uses of matter. Okay, let's continue. So what's P? Properties. What's S? Structure. What's U? Use of matter. Like I said, this is what we are doing. This is where I'm coming from. But let's start from this. You understand the background. What is it? Okay. This is my laptop. And I'm checking you guys' messages from here. So I don't want to be coming around to see my my phone camera. Do you understand? So from here, I can only see what you guys are saying and what you guys are doing. Well, I don't. But it's not. So let's go now, guys. So this is it. Like I said, this is what I'm coming at, or coming to, sorry. But if you understand the fact that, like, it's just like saying, when you are suffering, when you are suffering in Nigeria, the first thing in man, everybody will tell you is what they are following you from the village. Which means you have to trace your forefathers. Who do you offend? Who do your father can offend? One day there was a day your forefather went to the market and bought rice and 2 delivered beans, and then instead of paying, the forefather messed and ran away. And that's why he's following you. Do you get now? So this is the forefather of atom. This is where it starts from. From what? From science. Hey, sorry. From what? From science. Then down to chemistry. Then down again to this. Let's continue. If you have dropped this down, let's continue. If you have dropped this down, since chemistry studies non-living matter now, I say non-living, just non-living matter, yeah, correct? How do we relate this to atom? They classify matter, the non-living matter that chemistry is studying, the non-living matter that chemistry is studying, they classify it in 2 different ways, into the physical aspect and the chemical aspect. That means matter are classified in 2 ways, the physical classification and the chemical classification. Now in the physical classification, it is what we know as solid, liquid, and what? And gas. While in the chemical, it is what? It is element, compound, and mixture. Now, I believe everyone here, even though in SS1, you know what element is. Element is just a small particle that cannot be split into simpler units by ordinary chemical process. And compound is whatever a substance that contains 2 or more elements chemically combined. Hydrogen, helium, lithium. Then compound H2O, CO2, NaCO. Now what's the mixture? The mixture is just something that is physically mixed. Can also be separated by physical method. Now that's all this. So a compound contains elements. A mixture also contains what? Elements. Are you following something here? So now inside this element now, when elements want to combine, now back to this place, we are here now. We are here. We are done. We're almost here. I tell you this, what's time? 8:22. We have 38 more minutes. We'll achieve something this time. Now, what is this element now? So the element is the smallest particle. Element is a substance that cannot be split into simpler units by ordinary chemical process. Now, when 2 or more elements combine, they form what? A compound. 2 or more elements combine, they form what? A compound. Are you following something here? Now, the thing here is, let me tell you something. You see, they say a human cannot give birth to a human until the 2 major guys are in contact. And what is those 2 guys? The reproductive cell of a man and the reproductive cell of a woman. If they don't come in contact, they cannot form a human being, a new human being. And what is the reproductive cell? The sperm and the what? And the egg. So there must be contact of the what? Of the sperm and the what? And the egg for there to be a new child, which we call what? A zygote. Now we're getting out here also. So for an element A and element B to combine to form element B. A. Type that out. Element B. Type it out. Let me see who will type it out. Okay, type it out. Who is typing it? Who can spell that word I give you? That's a new word from Nelson Dictionary. Nelson Any Space Dictionary. Produced and manufactured in the United States of Nigeria. Who is typing it? Element B. I'm waiting for who will type it. I'm still waiting. So let's go, guys, now. Pending when somebody else. Pending when someone out there will type it for us. Are we good? What happened? Eh? This one has spelled it. Okay, my one does not update very fast here. It does not update easily. I have to be pressing it and pressing for your updates. Element B. Element AB. I'm still the first spelling, and the spelling has given me ginger. Oh, which spelling. Now let's go, guys. Let's go. Okay, that means you guys are with me. So the new element we discover in Nelson Any Space Scientifical Nigeria planet is called element B. Okay, now, so for 2 elements to combine to form a compound, For some elements to form a compound, something inside this element and something inside this element connect. Just like Jesus is Jehovah. Just like this guy now. This is daddy ink. Mommy duster. Daddy ink and mommy duster will cooperate and give birth to baby marker. Daddy ink, mommy marker, and give birth to what? Baby marker. Oh sorry, mommy ink, mommy duster. And the thing is, there is something inside daddy ink. So this is an element, and they give birth to this compound. The thing inside this element that allows this guy also to connect to themselves and form this compound, that thing is called atom. So in the definitive mode, or if you are looking at the definition, you can say atom is the smallest particle of an element that can take part in a chemical reaction. Atom is the smallest particle of an element, yeah, that can take part in a chemical reaction. And of course, don't be like Eba. A chemical reaction, when it happens, a compound is being formed. A new substance is being formed. You get something here? Good. Now, let's now go back to the story of atom. I think we are there now. So what is an atom? Write this down. An atom is a small particle, is the smallest particle. Is the smallest particle of a compound. Sorry, not compound, of an element that can take part in a chemical reaction. That can take part in a chemical reaction. Now that's what an atom is. So write it out. So now atom is that inside this element that combine with this element to form this compound. Do you get? Is that stuff. Now that atom is what I want to talk about today. The structure, the history, and the story of atom. If you are ready, let me hear you say amen. Type amen out. I'll give you guys 5 to 10 seconds to write that out. Like it. Now let's go. I think we are done writing what is on the board. So let's go back to the story of atom. Please, if you are here, you are live with us here. I am not joining my WhatsApp channel. And just for 3-4 things, to just solve questions, to give you solutions, to give you some knowledge I feel will help you in passing any exam you're actually planning for, whatever country you are, whether you're in UK, you're in US, you're watching me from India, South Africa, or from Nigeria or countries in West Africa. Join our WhatsApp channel. It's just Nelson Learning Space, or you can actually message this number on WhatsApp. And then you'll be given, just message someone and say Nelson Learning Space WhatsApp channel +234 041 517 75. text this number and say Nelson many space for channel. And we'll send it to you. So you can join it, and then from there you can actually get updates. You can have access to my PDFs, have access to my announcement, easy peasy, because here we are a family of future scientists, future doctors, future engineers. I want to build the young ones in a free, smooth, fun way in science. Back to this one now. So now that we already know how science leads us to chemistry, and chemistry leads us to elements, and elements lead us to atom. And then what is atom? The structure of atom. Let me start the story. I'm a good teacher now. I'm a good teacher, that's right. Now listen up everybody. For some of you that were expecting interactive board this night, pardon me, pardon Nelson in this space, no interactive board. I can't actually use slide today. But I think in the future we'll be able to use slide. If I can actually figure out how to use OBS Studio, I'm still yet learn it. With that being said, so just manage how to draw today. In our consolidation class, which will be on Friday, I think we'll have more access to more pictorial presentations. So now this atom, where did the story start from? The story started from the Greek scientist. Whereby this word was actually invented from the word atomos. And atomos actually mean, or in the corner meaning, it means indivisible. And that was just like a word that was just coined and left on an hanger in a particular building and left there for the more research. Sorry, let me attend to this message. Oh, okay, I've seen the AU, man. I've seen the AU, man. Let's go. Are you getting something here? So it was just hang there. The ideology of the term atom, even it's that 18th century down to the 20th century is where most of the understanding came from. Please give me pure water. Thank you. Is where that was called most of the understanding of most of the things we know now came from. I think Da Vinci, Robert Hooke, I think Isaac Newton was supposed to be in between the 17th and 18th century, I think so. So it was that period. It was hung there until 1808, the early 19th century. Thank you. The early 19th century, sorry, pardon me, or excuse me. Okay, yeah. So it was there until the early 19th century when John Dalton, so let's start the history now. So in your notes, what you write is history of the atom. History of the atom. Since I've written definition, I've written the story behind it. The next thing we're writing now is history of the atom. Nelson, learning, space, Nelson, learning. Yeah. So history of atom now. So it was in 1808, this guy, he was a good friend of mine. Believe me, we were classmates those days. 1808 now, John Dalton was the guy that gave us a more deeper understanding or a more deeper ideology around the term or the word atom. Are you following me? It's just like Charles Darwin came up with this, the theory of natural selection. If you're a medical student or a biology student, you know what I'm saying. They only came up with the idea, the theory or the understanding behind the natural selection theory, which is this survival of the fetus. It was actually close to being unexplainable until Gregory Mendel came up with the story behind genetics, which then he called factor. Now it was after he came now, and after some years, and he was actually understand. I think when those two stories collide, oh, that means factors or genes were what is responsible for what Charles Darwin was discussing or was explaining in his theory of natural selection. So same thing here. So John Dalton came up with what? With atomic theory in 1808. Atomic theory. And his atomic theory They actually gave us so many understanding about the atom, which of course, after some years now, we have actually seen as mostly actually did not stand again. Number one, there he said what? Atoms are indivisible. The atoms are what? Indivisible. That's the first thing. He said atoms can neither be created nor be destroyed. Neither be created nor be destroyed. Hey, you know what I say? Neither be created nor destroyed. He said atoms are alike in all physical. What happened? Someone say something?
No.
What happened? My network has been connected here. But let's go, sir. Okay, so unlike created or destroyed. They also said that atoms are similar in all aspects and different in what is it called? In and they differ from atoms of other elements in all aspects also, which of course also does not stand. The fourth one, they said atoms combine in simple whole ratio. That one also does not stand. But that's not the story behind what we're doing today. Now, this was what 1808 gave us. The understanding behind atom, and that was John Dalton input towards the understanding of atom. Then came, I think that was like 80 or 90 years later, around 1897, yeah, came, this was also my good friend, also good friend then, J.J. Thomson. Okay. J.J. Thomson. Now J.J. Thomson now came around this time, and the first thing J.J. Thomson did was a cathode ray tube experiment that give us the understanding into the fact that atom actually contains some small particles, but the first that was first discovered was electron. If I'm writing it down right, electron discovered through the experiment of what? Of cathode ray tube. Or cathode ray tube experiment. Cathode ray tube experiment. Now, are you seeing the way the story goes? Like I said, this thing here, it's a journey. It's a what? A journey. Look at where it started from 300-400 days ago. Then down to this. Then Dalton came up. Then down to this. And it keeps on going to 1911, 1913, 1932, downward like that. The understanding of X-ray. What I'm thinking. Robert A. Millikan, what it does to electron to give us a charge. James Chadwick, the neutron, Ernest Rutherford, the proton, Niels Bohr, the model of atom of Niels Bohr. And before we now get to the deeper understanding of how these atoms actually explain many things, when we now get to the Balmer series, the Rediscovering spectrum, the Horn's rule, the Alva principle, I want to teach you this simple thing, the key dimension. So please, if you are here with me, kindly be patient and follow me continuously. Follow me as I read this thing now, step by step, so that everybody will understand. So in 1897, J.J. Thomson came with the discovery of electron, and also using the cathode ray tube experiment. And I think around that same period also, he gave us his own model of atom. That means he gave us his own ideology of atom. First thing first, atoms can actually not be seen with the naked eye. Which is the reason why we always have atomic physics, or the chemistry aspect that deals with atom, is more of a theoretical aspect. But you have to just explain it with just what's it called? With a figment of a scientific interpretation. Are you following something here? Now, so in 1897, J.J. Thomson discovered electron and also gave us his own model of atom. And his own model of atom is what? It was more, he explained as a plum pudding. It's a very simple one. It's like porridge. You know how porridge is like? Let's say, for example, yam porridge. Yam porridge contains yam here, beans here, yam here, beans here, yam here, beans here, just like that. Do you understand? So these are the explain his own model of atom, which of course doesn't stand also. So many things have actually not stand after some years of a more eye-opening experiment. So two things have happened in this place now. J.J. Thomson gave us what? Discovery of electron, and also give us his own model of atom, which is what? Plum pudding model of atom. I've explained it here. If I follow you, say amen.
I have a question.
So okay, question. I can't even see it. This place. Okay, it's connected now. I will see it. Let me see your question. Who has a question? Come this. Okay, wait. Somebody. Hello, please, Jesus. I don't have to interpret this thing like this. This is somebody typed in another language. Let me try to pronounce your name. Hashit Kumat Matlowahal. Please, can you actually convert or translate your what you type into English? I can't actually read it. If you are asking a question, then please actually Jesus. Okay, let me do this. Is there a way I can actually do it? Can you see it? The same guy. Okay, let's see if you can type something in English now. Let me see it from there then. This one is not connecting first. Okay, I'm trying to like actually interpret that. I don't know. Can you please explain the capital the way to begin? Okay, that's me. I've seen your own. Is that are you the one with the question? What language is even that? That's Kenya. Is the person hearing us? No, like what I said here is. Yeah, I've seen the question. I want to try to see what this guy is typing. But it seems I can't. Jesus, I can't. Okay, I can't. I don't think there's any way I'll try to do that. Okay, so I think I've seen two questions here. Which one am I not answer? Why is this like this? I'm coming, please. I can't actually answer that question. Okay, calculative experiment. It's just more. I'm coming, please. I'm coming. Oh my god. I'm trying to interpret what that guy typed. Who asked that question again, Seth? Let me check. Who asked the question? What's this thing like this? Is there any question there again? It's not loading here. Can you guys hear me? Are they responding?
Not yet.
Not yet. It's not working here. Okay, who is that person?
Two people.
Why is this thing like this? Oh, I've not zoom it. I just say that these people should reduce their voice. I just want to listen to something. This thing is zoomed. Okay. I think I can't see it. I can't see anything. I have to be going down to that place. Let me just ignore this. If there's any question, just give me a sign out this question. It's not showing here. See late corner. We can't answer. Let's come out. Okay. So someone asked the question earlier. What was the question again? What was the question? Is it? What's the question? I'm trying to. That it's not working. I'm trying to link to Google to interpret the message in the chat, but it's not
Wait,
working.
you have a question.
Is there a question? What's the question? It's not showing here. I've made a mistake and there's no time. Okay. Does atom have a specific shape? And is it positively charged or negatively charged or even neutral? A specific shape? No. It does not have. What does that say? Electron or atom? What do I see? Atom. Atom is specific shape. Not really. The answer is not really. And does it have charge? The charge an atom will carry depends on the number of particles inside an atom. But I'm not there yet. Because firstly, atom can carry a charge of plus or negative. What is electrically stable? For example, let's use what's the person's name?
Ew.
You can't pronounce it.
Adeboale.
I like it showing here. I don't know why it's not showing here. Oh. What do you call it?
Adeboale.
Adeboale.
Dorcas.
Dorcas. So let's say Dorcas now D. When Dorcas is electrically stable, it means that in Dorcas, positive is equals to negative. So Dorcas will be what? Carrying 0. So Dorcas can be either be positively charged, as if Dorcas is an atom, can be positively charged, negatively charged, or electrically neutral, depending on the number of particles or of atom subatomic particles inside it. But we'll get there though. Let me put it again in Firefox. I'm using Chrome before. Hopefully it will show now. Okay. So, you know, I just want to ask a question earlier. I can't see the chart here again. What was the question? What was the question, please? Nobody answered. Is anybody answering? Let's go back. I think we have a very short time now. We have 1 minute, so let's be very fast on this. So we're done with this level now, right? Now then move on to 1911, 1913. 1911, 1913 came Ernest Rutherford. Ernest Rutherford actually gave us what? Discovered, he also discovered something. He gave us, he discovered proton. Yeah. So for some students, I might do some exam and I ask questions like this. First thing first is what? Jeremy Thomson used cathode ray tube experiment to discover electron. And the Rutherford with the what is it called? The help of Gregor and Madsen and some other tutelage, he used what is it called? He bombarded a cold foil with alpha particle. That explanation is not what matters now. What I want to get to understand is how the atom actually works. So I bombarded. What's the question? I want this to be.
Another name for plum pudding.
Oh, another name for plum pudding. There is no another name, but in a very simple way that I call the name for my students to remember. I call it porridge. Oh, I've rubbed it off. Porridge, like yam and beans porridge. A porridge. What about you have yam and beans? So Thomson said his belief is that he felt that okay, he sees the particle inside a what is it called? The particle an atom are immersed in the atom all the way around, like the way a porridge is. So porridge, P-O-R-R-I-D-G-E. Now back to this place now. Electron will give us what? Proton, and also give us his own model of atom. So we have Thomson model of atom, we have an Rutherford model of what? Atom. And now with this being said, I will rub off the board. Then please write this in 5 seconds. I'll rub it off. And then you can move to Rutherford model of atom. Okay, are we done now? Okay. Usman, why did they give us the definition of atom as smallest particle when you're okay? I think that was the formal definition. No! Rukaya! Or Rukayat. No. That question is a very beautiful question, but the reason behind this is number one, is those particles, can I see me? I want to see now. Can I see me? Okay, number one is those particles, those subatomic particles, that's a proton, electron, neutron, they're actually not independent. I don't know if you understand. They're not independent. Stylishly, the atom is actually independent. They cannot show the properties of elements by themselves, but atom can do that. That means like saying, no, let me see shadow. Imagine your shadow can actually leave your body and still be like you. Like your shadow leaves, like on the Monday morning you don't have to go to school. The shadow can wake up by itself, goes into the bedroom, bathe, brush. Well, most of you don't brush. So for some people that just brush, to not brush, just take the bag, bathe, eat rice, eat bread, and then go to school. That's what an atom can do. So number one reason is because the particles, the subatomic particles inside an atom are not independent. Number two, they cannot exhibit the properties of an atom just by themselves. Do you understand? Are you hearing me, small, or whoever asked that question? Has he responded? The questions I'm not showing you is very, very slow.
I thought the three subatomic particles that way.
Huh?
Are those the three subatomic particles that we have?
Yeah, when you at that level, yes. At that level, yes. So atom is the smallest unit of of an element that still behaves like the element, just like what molecule is. The molecule is the smallest unit of a substance that can retain the chemical properties of that substance. So we have a molecule of an element, a molecule of a compound. Same thing with an atom also. Atom is the smallest particle of an element that can behave like that element. So an atom of oxygen can behave like oxygen. An atom of chlorine can behave like chlorine. But electron alone is not oxygen. Electron alone is not, what is it called? Is not chlorine. A proton alone is not chlorine. I don't know if you understand. Do you get? Please respond if you get. So I think we have 9 more minutes. So I'll wrap up from there and then I think we'll call it a day. Has he responded?
Yeah.
Has he responded? No. I think let's continue. Where did I even stop? So Rutherford model of atom says that what is it called? That atom mostly contain empty space. Hey, I'm not over the board.
Ew.
What happened? The question?
I didn't have type no, sir.
What was that? Who said no, sir? What happened to the no? Are they in Katinuke? What was the no for? Please respond, and maybe it is lying on the door. We have to close. We have to continue this class next time. I don't want to exceed 1 hour at the end of our live classes. So, the Rutherford model of atom is just like this. According to me, said what? An atom contains just a small nucleus in the center, a tiny nucleus, and then an empty space, a lot of empty space, with electron orbiting around it. So this is the nucleus. Of course, in his own time, we don't actually understand, or we don't have the idea that neutron exists. So this is the model of atom. They're very simple, they're writing it down. What don't you understand? What specifically do you understand? Who is that person? What don't you understand? What don't you understand? Why do you retract your message? Rukaya and Adeyinka. What don't you understand? Okay, please, if you don't understand anything, type it plain so I can explain. So in our next class, I think we have to come up here. In our next class, what I was saying was the quantum numbers. Write it down, please. Quantum numbers. Can you see it? Because it's not soon, so I think we use this. Can you see it?
Yeah.
Please, if you can see it, type yes there.
Wow. They are retracting their message.
What is it?
Oh, they're asking my collab. Send the message, they retracted it. Oh, shit.
Can you see what I'm writing? This is it. They're not seeing it. This is it. This one. So I want us to talk about what we'll be doing next. Can you see it now? Huh?
You have a question.
What question?
You've answered it now.
Stop retracting message now. What's the question?
You've answered it.
The one I missed ask. What's the question? There's not. I can't go up. What is the question? So this is what we're doing next. Quantum numbers, K element shell / SPDF mapping. So I'll teach you this. Mapping. The three rules. I call it the three words, rules. Under this, we'll talk about the Alva principle, Pauli exclusion, and Hund's rule. Then we'll now move from here to what is it called? So I think let's ask a question.
God asked me my question.
What is your question, oh? What is your question? Then the three rules, the next one. The three rules.
A question. Are those the three? Are those
On the periodic table. PT is very table. So these are the four things we'll be doing next.
So this is now
Which is very
question. Are those the three? And you've answered it.
Are those three subatomic particles we have? I've said yes now. On this level, yes. On this level, yes. Have you heard it now? Yes. The androns are the quarks. Those ones are still deeper. You need a deeper explanation to understand them. So I don't want to go there now. Should we continue? So we said Rutherford known is what?
They said it's blurry, but it's clear.
It's not blurry, it's clear.
Blurry, so blurry.
It's clear, it's not blurry. Come on, answer your question actually burns time. So Rutherford model of atoms says atoms. What is it again? Don't again, please.
I wasn't calling you for. Yeah. It's not clear. Everybody says it's not clear. It's network.
Then Bohr model of atom. This one is electrons. Is there any question again?
No.
I think I will explain this one in our next class, in our next atom structure class. Because now what is it called? Now Bohr model of atom is still more of Rutherford model of atom. The only thing it just did is what? It tried to modify it, and its own model of atom actually explain hydrogen spectrum. Hey, can you see me? It actually explain hydrogen spectrum. So just these two down, but I'm using them to explain the next class we'll be going to under chemistry. Are we good? What's time? This is 2 minutes for time. So this is what we'll be doing next. And let me teach you this. Write it down, please. There are 3 subatomic particles. There are 3 subatomic particles. We'll continue from this under the structure of atom. But let me jot this down. Subatomic particles now. Number 1. I call it PEN. P-E-N. Proton, electron, and neutron. Let's see. The charge of proton is P. The charge of proton is positive, electron negative, neutron neutral. Then let us say the mass of proton is 1, and 1 electron is what? 1 over 1840 of proton. Now, if I look at the model of what is it called? Of Rutherford, we actually illustrate atom to do like this. In the cycle, we have P and N, or plenty P, plenty N. Then outside it, we have E. Many E orbiting around it at their individual energy level. We'll use to explain this key element and SPDF in our next class. So this is how it looks like. Now this P and N is inside the nucleus. So this is a very simple illustration. So maybe you pass secondary school level exam, high school level exams. And then the P and N, which are inside the nucleus, are. So we see anything how. Put your legs down. Can you see it now? Sorry. Can you see it? I think it's clear. Can you see it now? Can you see it now? Can you see it now? Yeah. Okay, good. Let's go now. So this is an illustrative model of atom. Now, this P and N found in the nucleus is regarded as the nucleons. The nucleons. Don't mix it up. As well as the nucleons. So the E orbits around it in their own energy level. Copy. So this E has a charge of negative. This P has a charge of positive. And this has a charge of neutral. Now on a deeper level, now if you want to understand something, have you just this one down? I want to move away from here. If you want to understand this now, can I say that what this? Please, if you like, I help the body of type amen, please let me show. So I don't want to hear sir. Type amen. If you know you have jot that down. Amen. Just type amen. Do you have it fast? You know your time with me. Yeah, okay. I've seen your own, Lisa. Okay, I think that's enough. Let's go there. I hope it's enough. Now, I think this class that's why they start 15 minutes. All of you are owing me. And what are you owing me? It's very simple. Just share the link of our WhatsApp channel, the link of our YouTube channel, and the link of our TikTok channel to your friends, to followers. Yes, we are going to be expanding to TikTok soon, where we'll be shooting short videos, explaining short, smart things in chemistry, biology, and physics, like how to understand the formula of projectile, motion, centripetal force, centrifugal force, all the smart things, simple harmonic motion, magnetic field, Fleming's rule, and all. And set with chemistry, balancing chemical equation, balancing various equation, chemical equilibrium, rate of chemical reaction, short videos of 2 minutes, 5 minutes, 10 minutes, or even shorts of just 30 seconds. We'll be posting them. So please share those things. Don't forget our YouTube channel, share it to your friends and followers, share our TikTok, and also share our WhatsApp channel. Yeah, our WhatsApp channel is for us to get you the text updates. Can you see this? Yeah, thank you so much if you do that. God bless you. Now back to class now. So we said the E is negative, and the P is positive, and the neutron is what? Neutral. Now, with that being said, and I said earlier that the mass of electron is 1 over 1840 of proton. How does that mean? It means that for you to get, okay, the very simple word, mass actually means weight. Just like weight has the influence of gravity. So for you to get, let's say this is a proton and 1 proton. For you to get the same weight of 1 proton using electron, that's why I'm putting electron, 1,840 electrons to get 1 proton mass. That's what it means. Now, with that being said, the buildup of electron here, or let me say, every atom has two major features. Which is what? Every atom has two major features, which is number one, atomic number. Then number two, atomic mass.
So when I started doing
K-root is on Saturday, the afternoon life class. So atomic number and atomic mass. Now the atomic number is the number of protons in an atom. So for example now, sodium, the number of sodium is 11. So how many protons does sodium has? It has what? 11 protons. 11 protons. Please jot this now. The atomic number is the number of protons in an atom. While the atomic mass is the number of what? P plus N. What's N? Type it out. What's N? What is N? Okay? N is neutron. N is what? Neutron. So atomic mass is equal to what? Is equal to proton plus neutron. Do you understand that? So which means, when I understand the feature of this guy, from the word, the atom, the mass of an atom, mass number, atomic mass. So like saying, I have three things here. I have this thing 1, I have this one 2, I have this one 3. Right? What?
When is the next class? Friday.
It's Friday. I mean, nice class is Friday. Friday. Okay, it's Friday. So now, look at these three things now. This guy is actually weightless. He's supposed to be infinitesimal in terms of mass. You need to get this guy 1,840 of this guy for you to get one of this one. Then you now have this three. Can I see this please? No, okay. You now have this three in a bag, and the bag has weight. Now, out of all these three things, which of them is adding weight? Only this one and this one. Because this one is actually, you're going to get 500 of it, it's not showing anything in the weight. So the atomic mass is from this one, the proton, and this one, the neutron. So if you get this now, so what does electron actually do? So we have no what proton does, I have no what neutron does. What does electron does? Now what electron does is what? Electron is in charge of what we call chemical reaction, or the bonding of an atom. Electron is involved with what? The bonding of an atom. Either sharing and giving. Look at this place. This atom, this sodium atom here in this state is electrically stable. Electrically stable means, or is electrically neutral, means P is equals to E. Means positive is equals to negative, is equal at this point. So in that case, you can say like this. Is that me? Huh? I don't hear you.
No.
Okay. Now let's use sodium for example. So here sodium is what? The atomic mass of sodium is 11. Atomic mass of sodium is 23. So how many protons does sodium has? 11. Because atomic number is equal to what? It's equal to proton. And in this state now, sodium is actually neutral. Which means the number of P is equal to the number of E. So here, how many electrons does sodium has? 11. Now how many neutrons do we have? Simple. So it is what? The mass number is 23 is equal to P plus N. So N is equal to what? 23 minus P. So what's P? P is 11. 20 minus 11 is what? 12. So the answer is what? 12. Can you see it? Are you sure it's clear? That is it. So the work of electron here is when atoms want to bond to another atoms, or even their own atoms, they share their electrons, or they give and take to become molecules. Either molecule of compound or molecule of elements. Another example here, let's use oxygen. Look at, there's no plus or minus, which means oxygen is neutral. Oxygen is 8, 16. So how many protons does it have? 8. And in this case, it is neutral. So electron is also what? 8. 16 minus 8, 8. Now let's understand how electron comes in. How does atom become positively charged or negatively charged? However, Immediately an atom becomes charged, that's having positive or negative in its air, it becomes a ion. So this is sodium, atom. This is also sodium, with the positive on its head. It's already an ion. This is oxygen, atom. When oxygen has a charge on its head, minus, it's already a what? An ion, or a ion. If you want to call it a name that will make it easy for you to remember. Now, how does it has minus or positive? That's the case now. Every element can either give out electrons to become balanced or take in electrons to become balanced. When they give out electrons, they become positive. They become positively charged. Meaning they are now like a lender, they're like a giver, they're like a bank. They have positive. When you give out one, if you give out one, you become what? Plus one. When you give out two, you become what? Plus two. When you take in three, you become what? Minus three. So when you take in, you become what? Negative. Why? Because now, for example, let's use dog and cat. Cat's electron proton was 11. So which means that in this case now, the P is equals to what? E. And how many electrons does it have? Proton does it have? 11. How many E? 11. Dog gave out. Are you following? Are you following? Are you following? So you gave out. First look at this level first. Then cat is 19. Then cat receive. Or cat is 17. Cat receive. If cat is 17, yeah, it's neutral. So P is equals to E. Which means 17 is equals to what? 17. How many did dog give out? Just one. How many electrons? One electron. So when you give out one electron, it becomes dog plus 1 abi plus. Meaning P is still what? 11. And then it has given out 1 E from 11. So how many does it have left now? How many E does it have left out of the 11 one it gave out? Right? Type it out. How many E does it have left? How many E does it have left? I'm waiting. If you're here with me, how many E does it have left? Okay, it has 10 E, 10 electrons left. Do you get it? So, because it has given out 1, and that's all, which means, in that scenario, the normal D electron is how many? 11. But D plus electron is how many? 11 electron. D plus was 10 electron because it's giving out 1. Meaning plus 1. Now, cat took in minus 1. It took in minus 1 electron. It took in 1 electron. So in that case, I become D minus. Now D minus, the P is still what? Is still 17. And the E, as you're saying 1 E electron now. You're saying 1 E. So 17 plus 1 is what? 18. That's also D minus. And if you receive 2, that's 17 plus 2. It was 2 minus. If you receive 3, it will what? 3 minus. If it does not give out 3, it will be 3 plus. Please, do you understand? That's how it works. Simple as ABC. Simple as ABC. Now, if you understand what I just said now, I think we'll wrap up the class I'll be wrapping up the class by giving you a short, sweet classwork, an exercise that you just use to juggle your brain, if you understand me. If you understand me, I'll give you a short, sweet classwork to juggle your brain. So you understand that every particle can either be what? An atom or a molecule or a ion, but I didn't atom and a ion today. So in that case now, we have numbers of proton, numbers of electron, and number of neutron. Then we have atomic number and atomic mass. Can you see this one?
Yes.
Okay. Now, let's start with, I'll solve only one for you. Let me solve another one for you. Let's see everything once. That one is network. Let it be. It's not you, it's network. Is it okay now, can you? Now let's do it. Okay, I think I'll do it this way. Here is particle. So the particle can either be what? Can either be A or ion. And then we have proton, we have electron, we have neutron, we have atomic number, we have atomic mass. Are you following? So I'm going to do one for you, just one. Then you do the other ones. So let's start with how do you know an ion if you carry charges on his head? If you carry positive, it means he has given out. If he carries negative, it means he has taken in what? Electron. Proton doesn't change this because it doesn't give out proton, it doesn't take in proton. Now, so let's start with, let me give you an example of I think let's use fluorine for example. Fluorine is 9. It's really a common one. 997. Are you there? Now, how many protons will fluorine have? 9, because the atomic number is 9. How many electrons? Fluorine is stable, so it's 9. How many neutrons? 19 minus 9, 10. What's the atomic number? 9. And what's the atomic mass? 19. Now, you want to class up with number 1. Look for calcium. I'll give you some and then you fill in the box. Fill in the what? The box. So first of all, electron. Calcium 2 plus. So the electron, I don't know, the neutron, the atomic mass is 40. Find the neutron. Find the electron. This one is 20. And number 2, aluminium. The proton is 13. Find the atomic mass. Find the atomic number. Find the neutron. The electron. That is 27. I'm sorry, not 27. 14. Number 3. Cl minus. Cl minus. The neutron, the atomic number, sorry, is 17. Neutron is 18.5. Find the electron, find the proton, find the atomic mass. Then number 4. Number 4. Cl minus number 4. Look for phosphorus. The electron is 15. The atomic mass is 6. Is 31. So I'm looking for close. And number 5, the last one. So I only use 5%, then we'll close for the day. So number 5, look for. Huh? You're not seeing what?
Not seeing the numbers.
Okay, great. Start to look like you want. I don't do that for you now. I don't do that.
Can you see it now? It's showing now. But I don't want you to zoom in. Can you see it now? Docker similarly. Can you see it? Yes or no? If you can't see it, please let me know. Similarly, can you see it now? Okay. I think let's stop in number 4. Let's stop here. Let's only do this once.
Come on. The answer.
Huh?
Put the answer.
No, I'm seeing that was just now. So how many have done the answers? If you have done it, I'll solve it. I'll give you guys just 3 minutes to finish these 4 questions. Then we'll finish it. Then we'll close for the day. Wow, who is this? Oh, thank you so much. I don't know who is this.
Oh. Can you see?
Somebody messaged me.
Can you see it?
See what?
The answer.
There's a question. Okay, I'll come and say it.
It's going up.
Huh?
It's going up.
Sorry?
It's going up.
What's going on? What's going on?
Not the time.
I'm not understanding it.
Put it and bring it up.
Somebody else messaged me. Okay, can we solve now? I think you guys must have tried doing some things, right? Please, if you know if you know you are done with your own solving, and you think I can solve now, just type good. Send me good, and I'll go ahead and solve. You just type good. When I see some at least 3, 4, 5 good, and then I think we'll go ahead and solve it. Ah, Jesus. How many good now? Eh?
3.
3. Okay, that means 3 people are already done, right? So please, I think I will solve it now so that I can close for the day. That was a mistake. I am on fire. It's a mistake. I'm coming. I'll stop it now, guys, and then we'll close. Okay. How many good now? Done. Posted all. Okay, let's solve them. Let's solve them. So calcium 2 plus, the proton will be what? 20, atomic number. Then electron is minus 2, because I was giving out 2. So it's 18. Then the neutron is 40 minus 20, 20. This is what to do, correct. Then for aluminium, the proton is also the atomic number, so 13. The proton is also the electron because it's actually stable, electrically neutral now, so it's what? 13. Then the proton plus the neutron is atomic mass, that's 27. Correct. Then number 3, this guy has given out 1, he has received 1 electron, that's of minus, he has received 1. If that's the case, 17 is the atomic number, so 17 is the proton. So he has received 1, 17 plus 1, 18. These 2, neutron plus this, is, what is it called? Is the atomic mass, so that's 35.5. Alright. Phosphorus. Yeah, it's electrically neutral, it's electrically stable, so which means E is also P, so 15. Then neutron. Neutron is atomic mass minus proton. It's not minus 15, 16. Then atomic mass is not proton, that's 15. Correct. If you get everything, type it out, say 4 over 4. But if anyone you miss, mark it for yourself. 4 over 4, 3 over 4, 2 over 4. Let me see your answers. And then, ladies and gentlemen, welcome to Nelson Learning Space. This is where we'll be closing. So, let me see your final answer. Is it 4 over 4, 3 over 4? What do you get? What? Okay, Chipu, you have seen your own. Gazi, you have seen your own.
But I did not see.
Yeah, that's what they will say. Okay, everybody got 4 by 4. That's alright, so no problem. So guys, we close there for today. I'll meet again on Friday. Do well to share our account, TikTok, WhatsApp channel, and YouTube to your friends. And don't forget to like, to comment, ask your questions, and let's keep on learning. Bye for now. Okay.